All right, when I see two functions, 5x times this, what's in parentheses, I know I'm going to use substitution. What I typically do is bring constants out front. I'm going to substitute what's in parentheses, so I'm going to throw that first. And then I'm going to write the x dx, because that's going to end up being my outside piece. So the inside is x squared plus 1. So in other words, I'm going to substitute that as u, because it's going to be easier to take the antiderivative. So over here, I take the derivative of this function with respect to x, which would be 2x. And I can multiply both sides by dx to cancel the dx. So I end up with du equals 2x dx. Well, the x dx is fine, but I need to get rid of the 2, which is no problem. I can just divide both sides by 2. And I typically write the constant out front, so that's 1/2 du equals x dx. So where I see x dx, I'm going to replace it with 1/2 du, because I can't have x's in this antiderivative because my function now has become u. So rewriting it, I write everything in terms of u. Inside the parentheses is u. I need that square on the outside. Where I see x dx is 1/2 du. And now from here, I can move the 1/2. I can bring that out front, so that becomes 5 over 2. And then u squared du. Take the antiderivative of u squared, which would be u to the third over 3, because we're adding 1. And then finally, so that's going to be evaluated at 0 to 2, finally plug back in what my u that I substituted, so that gets plugged back in. I can go ahead and multiply that, so that becomes 5 over 6. U is x squared plus 1, and this is to the third power, and I evaluate it from 0 and 2. So now I'm to the fundamental theorem of calculus part, where I'm going to do the f of b minus the f of a. So I have 5, 6, which can just be thrown out front. I'm going to plug in the 2, which will be 2 squared plus 1 cubed, minus, I'm going to plug in the 0. Again, this is my f of b minus my f of a. And from here, I get 5, 6. This is 4 plus 1, which is 5 cubed, which is 5 times 5 is 25, times another one, 125. And then this piece becomes just 1 cubed. So I get 5, 6 times 124, and I can put that over 1 because I'm going to be multiplying the top, which is going to be 620. So 125, 5 times 124, and then over 6. And it looks like I can divide a 2 out of the top and bottom. So reducing the fraction, I get 310 over 3, which is my final answer.